parallel and perpendicular lines. So our objective here, we want to find slopes and equations of parallel and perpendicular lines. We know a few things coming into this that we're going to use in this video. Number one, we know what slope is. Slope is a measure of a line's steepness. And let's remind ourselves that slope is a fraction. And we, in shorthand, m is equal to the change in y over the change in x. Number two, we know the point slope form of the equation of a line. Y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is any point on the line. And number three, we know the slope-intercept form of the equation of a line. Y equals mx plus b, where again, m is the slope, and in this case, b is the y-intercept. Well, let's first define parallel and perpendicular lines mathematically. Parallel lines are two non-intersecting lines that lie on the same plane. Probably way back when you talked about it like railroad tracks, two lines that go on forever and never touch. Okay? Key for us is that parallel lines have the same slope. Okay, perpendicular lines are two lines that intersect at a right or 90-degree angle. While parallel lines have the same slope, perpendicular lines have slopes that are opposite reciprocals. So if it's a positive, we're going to change it to a negative, and we're going to flip the fraction. The reciprocal is 1 over the fraction, which means you change numerator and denominator. We also want to note with perpendicular lines, when their slopes are multiplied, because they are opposite reciprocals, the product is -1. Let's take a look. Okay, example 1, write an equation of a line passing through the point -2, 5, and parallel means same slope, to the line whose equation is y equals 3x plus 1. Well, it's kind of nice. This line's equation is already in slope-intercept form. So we know from this equation that the equation of a line parallel to it is going to have the same slope. Okay? And we're told that we have a point we want that new line to go through. We want the point for the new line to go through the point -2, 5. Okay, so we have a slope and we have a point, so we can use the point slope. And again, I abbreviate point slope as P-S, if I can write my S so it looks like an S. Okay, we know the point slope form. We can go right up here to the top and things we know already. Here's the point slope form of the equation of a line. So we'll come back down and the point slope form says y minus y1 is equal to m times the quantity x minus x1. Let's substitute. Y minus 5 is equal to the slope times x minus -2. Let's clean it up. Y minus 5 is equal to the slope times x plus 2. And here we have, okay, we wanted an equation. We got an equation. This is the point slope form of the equation of a line, and technically we're done. However, if they wanted this to be in slope-intercept form, well, we'd want to solve this for y. So y is equal to 3 times x is 3x, 3 times 2 is 6. Let's add 5 to both sides, and then let's clean up the right side. And 3x plus 11. This is, now we have the slope-intercept form of the equation of the line. Notice, if you will, it's easy to compare these two. They have identical slopes, 3 and 3, yet they have different y-intercepts, +1 and +11. That's how you can tell they're parallel. The exact same slope, but different y-intercepts. Okay, let's do another example. We'll pull in a bit of our general form and we'll do perpendicular here, which is a slight bit more complicated, but not too much. Okay, example 2. Find the slope of any line that is perpendicular to the line whose equation, again it's in general form, is x plus 4y minus 8 equals 0. And then write the equation of the line passing through the point 3, -5, 3, -5, and perpendicular to this equation right here. Well, we need the slope. Okay, we're perpendicular, which tells us that the slope of our new line is the opposite reciprocal of the slope of this line. So let's find the slope of the given line. So part A here tells us we need to find the slope of the given line so that we can then take the opposite reciprocal and find the slope of any line that is perpendicular to it. So I'm going to find the slope, and I'm going to do that by, writing in slope-intercept form. In other words, solve for y, because that gives us the slope. So here's the equation in the general form, x plus 4y minus 8 equals 0. Let's solve this for y. Okay, 4y is equal to -x plus 8. Subtract x from both sides, add 8 to both sides, and then divide both sides by 4. So I have a -1/4 times x plus 2. Okay, so the slope of the given line is -1/4. We had to find that first. Slope of given line is -1/4. Okay, therefore, to answer part A, which says find the slope of any line that's perpendicular, well, the slope of any line that's perpendicular is going to be the opposite reciprocal of the slope of the given line. Okay, so therefore, slope of any, and I'll abbreviate perpendicular with that symbol right there, that means perpendicular. Any perpendicular line is positive, opposite, reciprocal. Flip the numerator and the denominator. Okay, the opposite reciprocal. Okay, or because 4/1 is just 4, the slope of any perpendicular line is 4. Okay, so there you have it. That was part A. I want to make a note here. Note the slope of the given line. Okay, note -1/4, the slope of the given line times the slope of the perpendicular line is equal to -1. And that was a comment that we made a little earlier, that the product of the slope of two lines that are perpendicular is going to be -1. Well, now let's solve part B here, because we know the slope of any perpendicular line is 4. So we have the slope of the perpendicular line, and we have a point. Okay, so we know the slope is 4, and we have a point we want this line to pass through, the point of 3, -5, right up here. So let's use point slope. We got a point in the slope, and we'll use point slope to find the equation. Okay, so we know point slope, y minus y1 is equal to m times x minus x1. So y minus the y coordinate, which is -5. Again, the parentheses help. Whoops, you can't see that. I'm sorry about that. So here we have y minus y1 is equal to m times x minus x1. Okay, y minus -5, and I use parentheses so as not to lose the negative. The slope is 4. times x minus, and again, I usually use parentheses whenever I substitute. Okay, now I can clean it up. Y plus 5 is equal to 4 times x minus 3. And there we have the point slope form. And all it asked us for, let's go back up here. All it asked us for was write the equation of the line that's perpendicular. Well, there you go. I wrote the equation of the line. All right, I wrote the point slope form of the equation of the line. Now again, if they'd like it to be in slope-intercept form, we'll just solve for y. So y is equal to 4, let's distribute the 4x minus 12, and then let's subtract 5 from both sides, and then we're going to clean up the right side. And here is the slope-intercept form of that same perpendicular line right there. So there you have it. The key here is, of course, that parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals.